In Canada, electrical installations follow the Canadian Electrical Code, CEC, Part 1, CSA C22.1, with possible provincial amendments, e.g., Ontario Electrical Safety Code, which adopts the CEC with some Ontario-specific bulletins. For transformer secondary conductors, low-voltage dry-type transformers rated 750 Vs or less, the key requirements are in Section 26, Installation of Electrical Equipment, specifically rules around 26-256, overcurrent protection, and 26-2158, conductor sizing. The standard minimum sizing rule is: transformer secondary conductors must have an allowable ampacity of not less than 125% of the transformer's rated secondary current, full load current. This is stated directly in multiple reliable sources, referencing CEC Rule 26.258.1 and 2, as well as related rules like 26-256. How to calculate it? 1. Determine the transformer's rated secondary current, ISEC. For single phase, ISEC, kVA x 1000, secondary voltage. For three-phase, ISEC, kVA x 1000, secondary voltage x3. 2. Minimum conductor ampacity, ISEC x 1.25. 3. Select the conductor size from the appropriate CEC ampacity tables, e.g. Table 2 for copper, or Table 4 for aluminum, based on insulation temperature rating like 75 degrees C or 90 degrees C, installation conditions, and any derating factors per Section 4. Exceptions. Allowing smaller conductors. Per Rule 26.258-3, primary and secondary conductors are permitted to have an ampacity less than 125% of the rated current if they are protected in accordance with Rules 14-100. Tap conductor rules, e.g., limited length, like 7.5 mt, max in some cases, and 14-104, conductor overcurrent protection. This often applies when overcurrent protection is provided on the secondary side or via primary protection in certain configurations, effectively treating the secondary conductors as protected taps or feeders. Additional notes. Primary conductors follow a similar 125% rule. If the primary overcurrent device exceeds 125% of primary current, allowed under specific conditions like Rule 26.254-3 for the next standard size, secondary protection may be required, and conductors must then comply with the tap rules to avoid undersizing risks. There is no fixed minimum AWG size, e.g., no universal NUMT 14 or NUMT 12 rule, like in some NEC scenarios for small control transformers. It depends on the transformer's kVA rating and calculated current. Very small transformers might result in small conductors, but always at least meeting the 125% ampacity, unless qualifying for the tap exception. Always verify with the latest CEC edition, e.g., 2021 or 2024, local amendments, especially in Ontario via ESA bulletins, and consult a qualified electrician or AHJ, authority having jurisdiction, as interpretations can vary slightly. This 125% rule accounts for continuous loading and provides headroom similar to the NEC's approach, but tailored to Canadian requirements. If you provide the transformer's kVA, voltages and phase configuration, I can help calculate a specific example.